Hello guys, welcome back to a new physics video tutorial. Today we're gonna explore the projectile motion through this Kognity simulator. The first thing we're gonna do is to make sure the simulator doesn't has air resistance. Then we will set the cannon at 50 degrees over the horizontal and an initial velocity of 50 meters per second and see what happens. Also, we're using a golf ball because our cannon can shoot many types of balls. And we can see that our golf ball didn't hit the target on the floor, so we will try another angle. Let's try 60 degrees, why not? We can see it also didn't hit the target. Well, let's try 80 degrees. Oh, we almost hit our little David over there. Let's try 70 degrees and we see that we hit the target with 70 degrees. Now here comes the good part, because we will try to use our kinetic equations we learned from our beautiful physics class to get the time the ball spends in the air. Also, we're gonna try to get the range, that is the horizontal displacement, and the maximum height the ball gets. First of all, we're gonna make a little sketch of the situation in our notebook to know what the factors are. We can see the vertical initial velocity is the sine of 70 multiplied by 15. So we can get that with our calculator, and we know that it is 14.0954. We also know that the final velocity, vertical final velocity, is the opposite of that, that is minus 14.0954. We also know the acceleration is minus 9.81, that is the gravity, and that are our values. We have available to get our other values that we want to get. Time was easy. We used the formula of acceleration equal to final velocity minus initial velocity over time. So we get the time is 2.8737. For the range, I went back to the page on my notebook where I have all the other formulas that I still don't know by memory, and try using the one that says displacement is equal to a half multiplied by, you know the rest. But it didn't work, so I tried using the one that says final velocity square. That also didn't work. So I tried using another one, and then I realized that I was replacing the values with the vertical part values, and the range was the x displacement. So I did what I was supposed to do from the start and used the only URM formula we have to get horizontal values. So from multiplying 5.1303 by 2.8737, 14.7429, that's our range. I forgot to mention that the second value, that is the horizontal initial velocity, I get that from 15 cosine of 70 degrees. Last but not least, we're gonna get our highest point the ball gets through the parabola. So I use the first formula I tried to use, then the other one, and I get 10.1268. So we currently have our time, our range, and our highest point. We gotta confirm that with this tool Kognity gives us. And now we see that our values are right, our values are correct, so we move to the next part. Yes, we're not done yet, but our mission is close to be successfully completed. Now we gotta do some predictions based on our physics knowledge. The first one is, will changing our golf ball to a actual cannonball affect the trajectory of our parabola? My prediction is no, because as we don't have air resistance, we will get exact the same trajectory, like in the video we saw in class, where some people dropped a very heavy ball and a couple feathers in a no air chamber, and they both reached the floor at the same time. We shot the cannonball and we see that our prediction was correct. The heavier ball did the exact same trajectory as our previous ball, because there is no air. Now, back to our golf ball. Will air resistance affect the trajectory and change it even if we have the same ball? My prediction is yes, because as we now have air resistance, the ball will struggle crashing with the air that will stop it. We shoot the ball and we see that again our prediction was correct. Both the range and the highest point were lower because the air was resisting to its movement. Our last prediction will be if air resistance will affect more or less the cannonball or the golf ball. At first I thought the cannonball was going to be the one affected the most, but then I investigated that the relation between the surface and the mass of the golf ball had more surface and less mass, and that makes the air resistance to impact more on that ball. We shot the ball and we see that it's right, the golf ball, surprisingly for me, was more influenced by the air resistance than the cannonball. How surprising and fascinating are physics. Our last mission is to see the relation between an independent value and a dependent one. So we pick, why not, the initial velocity and the maximum height. We can see that by increasing the initial velocity, our ball will go higher. So we can do predictions like, if we put an initial velocity that is lower from the previous one, our maximum height will be also lower. To finally conclude and to make a little summarize of everything we did, through the kinetic equations we know, we were able to know the time, the highest point that the ball reaches, and the range of the parabola it makes. And we did get the right values. Also, we learned that air resistance makes our shots go lower, and that the more surface and less mass an object has, the more it will be affected by air resistance. But as long as it has not air resistance, every object shoot at the same angle and with the same initial velocity will have the same trajectory. And we learned the relation between independent and dependent values. I liked a lot this practice, and I'd like to do more practices like this. Even I think I might put physics in higher level just because this practice. Well, that's still debatable. And that's my conclusion. Thank you for your attention and see you on the next physics video tutorial, guys.